Let's do some math with this. We're going to use our table of values to figure out how much potential is available in our cell. So what we're going to start with is just kind of looking at the table. Where does silver live? And I can look on my table and I'm like, okay, where is silver? Silver, silver, silver. Here it is. And then let's see, what else do I want? I want to know where lithium is. Here's lithium. So we have two different ways of looking at this. We can look at it in terms of the cathode and the anode, or we can look at it in terms of oxidation and reduction. Let's go ahead and see how this plays out. So what do I have? I have my little half reactions, or Ag+. I'm going to gain an electron and go to, let's put my negative sign in there and go to Ag solid. And then the other one is my lithium. And what am I doing? I am losing an electron on this side. Plus Ag. Oops, plus lithium, not Ag. We did magic. Plus. All right. Now let's do our cell diagram. Remember, let's see, we start with the thing that is a solid going to its ion. And then here's my salt bridge. And then what am I doing? I'm going to take an ion plus and turn it into solid. Just kind of working our way through the anode and the cathode. So let's see, what do I have here? Oxidation, reduction. Reduction is gain. Here's reduction. Here's oxidation. And then cathode, anode, red ox. That's not helpful. Red cat. An ox, red cat. Jeez. Oxidation. Why did I just do that? So an ox, red cat. So I want the value of my potential for Ag+. And what do I look? I look here and I see here's my 0.80. And then I'm going to subtract my anode. So I look here, I'm subtracting my negative 3.04, but I look at this, I'm like, but that's positive. So let's think about why that is. How is this written? This is written to say that there is 3.04 volts available if it is what? Or actually, it's saying it would take that much if I am gaining electrons. Well, I look here and I'm losing. So just like our equilibrium constants where we would have to flip it, or if we flip the reaction, we have to do something to the equilibrium constant. This would actually be more like your delta H. So when you were doing your combining equations for enthalpy, if you switched it, then you had to change the sign on the enthalpy value. This is exactly the same. If I have my reaction, my half reaction is going the opposite way of what it's listed on the table, I'm going to change the sign. So give this one a go. See if you can't justify how I got to here. Okay, let's look at it. I have aluminum. And what am I doing? I am going to lose 3 electrons plus my aqueous solution. Why do I keep doing this? Al3 plus. And then the other one is I'm going to start off with my mercury ion and then gain 2 electrons and go to solid. Well, liquid. It's mercury. So I want to look at my tables. Let's go ahead and erase here and here. So I'm not messing up those values. Let's see, where is my mercury? Here we go. And then my other one, aluminum, is up here. Let's write my cell diagram. I'm starting off with aluminum. It is going to go to its ionic form. Here's my salt bridge. And then I'm going to go from my ions in solution and form liquid. Aqueous. Aqueous. So that's my cell diagram. Oxidation is loss, reduction is gain. What's happening here? Well, for doing my plus and minus, let's say I'm going from mercury. Let's just write this out because I'm getting ahead of myself. Going from mercury, so oxidation, reduction, oxidation. There we go. And then for my cathode, anode, well, my reduction is my cathode. So my Hg2 plus, there's my 0.85, and it's a positive sign that's in the same direction. So this is listed as reduction reaction, so I don't have to change the sign. The other one, though, my aluminum, is an oxidation reaction, so I'm going to have to change the sign on it, so it becomes 1.66. And then this is the total potential that I have available for this cell. So pretty cool. So what I want you to do for this one, and I'm going to end here, because we'll pick this up on Wednesday. I want you to be able to do these without looking. So I'm not going to give you the answers right here. I mean, you can see what the E cells should be, but I want you to justify those E cell equations and look at it in terms of write your half reactions for both, identify what's being oxidized, what's being reduced, and write a cell diagram. So come in on Wednesday, and that is when we will pull all of this together and write all those things up so we can do our last couple of little things, and that's just talking about the glory of equilibrium constants. And then that's it. You are done for the quarter. Yay, you. Okay, I'll see you Wednesday.